Good morning, everybody. Thank you for joining us today in our webinar series. And today, topic, high temp, high stakes, pressure pros for combustion monitoring, focusing mostly on gas turbines, but there's a lot of other applications for this as well. This is our schedule for our webinars, the 2021 series, part one. We'll have another series upcoming as well. Be sure and join next week for talk about our wireless system and how you can go wireless at your plants for vibration monitoring instrumentation. So, for those of you that don't know about PCB, I work for PCB directly. The mobile shop is part of PCB. It's one of the businesses underneath PCB. PCB was founded in 1967. Our headquarters is right outside of Buffalo, New York. Very cold and snowy area this time of year, but very beautiful. Our facility there, manufacturing, is very vertically integrated. We manufacture from the entire assembly parts for all of our products that we make. So it's we have a machine shop on site. If you look at that picture at the bottom right, the bottom building is our actual machine shop, 50,000 square foot center. We make all of our components there to make our sensors and cables, and our other products that we make is all done within these two buildings. And we have a manufacturing facility in Halifax, North Carolina as well. Some of you know a company named Devco. We acquired them in 2019, and they are part of PCB now, and they are, integrated within our business today. We manufacture a lot of the Devco products now in North Carolina as well, with some manufacturing still back in the West Coast where it used to be. We are a leader for sensors, world leader for sensors for industrial, power gen, aerospace and defense, and automotive industries. We make probably more sensors than any other company in the world. We're probably number 2 when it comes to high temp sensors for extremely high temperature applications with our accelerometers and dynamic pressure sensors that we manufacture. Mobile shop, like I said earlier, is part of PCB. It's a PCB company. They have a facility in Cincinnati. They moved into a new building last summer. Cincinnati used to be a couple buildings spread out across the parking lot. Now they've combined into one facility. It's a very nice facility now. World leader in calibration systems and services. Check out their website and you can see everything that they do, themobileshop.com, and you can see all the different types of products, calibration systems, and services that the mobile shop can do. This is me. Again, my name's Dave Martin. I am the business development manager for PCB. I cover a geography for the company, mainly the Western United States and Latin America, and Western Canada as well. So I help develop new business in these areas, along with support the sales force in applications, and provide product knowledge and application knowledge. I am a certified Category 3 vibration analyst, part of API 670 committee. I've been in that committee for probably 20 years. Graduated from UC Davis many years ago, mechanical engineer. And once when I was younger, I owned a air conditioning company and refrigeration focusing on commercial and industrial air conditioning systems. And I got kind of crazy when I was younger and ended up owning some donut shops and gas station convenience stores all at the same time. kind of stressed me out. So I sold everything after about 12 months and kind of started focusing on vibration and pressure products. For back then, it would have been a company called SKF Condition Monitoring. And I went to work for them after I sold all my businesses. So, you know, PCB Mobile Shop, we all know, we know power gen. I have worked in power gen personally for probably over 25 years. My major focus has always been on power gen plants. So we know how a power plant works. We know how proximity probes work, and we can troubleshoot that. We understand combustion dynamics. You know, our company, Template Sonics, can do tank gauging. Our company within PCB called Larson Davis knows industrial hygiene. Ground fault detection monitoring from our company called Accumetrics. And we've got some products that can monitor slow speed hydro turbines as well within our portfolio. So, you know, we understand power gen. We have products for most parts of a power plant. So now to the core of the presentation, high temperature dynamic pressure sensors. We are probably number 2 in the world for manufacture of these within the power generation industry. These are used for combustion instability, typically on aeroderivative gas turbines and large frame gas turbines as well. We are the OEM supplier to some major OEMs, not to mention any names, but we make them their sensors for them, and they're branded with the company's name on it. You know, other applications for dynamic pressures sensors is nuclear power plants, aerospace flight engines, and some ground-based test engines. So you would, if you went into any of these types of areas, you would more than likely see a PCB sensor, pressure sensor. So in our range of dynamic pressure sensors, there's not just our range, but everybody's range. There's 3 different types. We've got what we call a remote sensor. So that's typically mounted way far away from any extreme heat. Can handle only 250 degrees Fahrenheit. It's an ICP style sensor with a voltage output. All the electronics are built into it. And it's usually mounted on a long tube. They call it an infinitube within a case or enclosure. And it's looking at dynamic pressure oscillations via that method. There's also a style called a close coupled sensor. So it's a ceramic crystal type of sensor, can handle around 500 degrees Fahrenheit, and it's not mounted actually on the turbine, but it's mounted a little ways away from it, depending on the application, depending on turbine. So there's going to be a tube that goes straight to the sensor, and it's mounted away from the heat for monitoring combustion dynamics. And that method and the other method were what they used to do many years ago for looking at combustion dynamics on gas turbine. And maybe, I don't want to date myself too much, but 10 to 15 years ago, they started OEMs started looking for on-turbine style sensors. And there were a couple of companies that started making them. We were one of them. So we came out with our UHT12 crystal direct mount dynamic pressure sensor, and it mounts directly on the combustor of a gas turbine or other real hot extreme environment application. Typically, these sensors, when they're mounted on the gas turbine, are used to tune the gas turbine. Sometimes they're just turned on to tune a turbine twice a year, then they turn it off and they never really look at the data again. Some companies monitor the combustion dynamics all the time. So yeah, just these sensors, all of them are used to detect oscillations when the turbine's running, and then these technicians, or they're typically called tuners, are able to go out and fine tune the gas turbine's fuel and air mix so they can get that optimum so there's no damage to the gas turbine, along with meeting emission standards and fuel consumption. So yeah, why measure combustion dynamics? And there's a lot of reasons. Most major OEMs, when they made their turbines, have done something to look at it, whether it's been mounted temporarily when they're starting up a turbine after an outage, or installed all the time. And there's always been some sort of system, goes way back many years. But getting, if there's fluctuations or oscillations or instabilities, it can cause a lot of damage to a gas turbine. You get some flame blow off. There can be a flashback, like an explosion within the chamber, which in turn can cause damage to the combustion chambers. If you've got the wrong fuel air mixture, you can increase your fuel usage, which can be very expensive. Natural gas is pretty expensive. That's one of the most expensive parts of operating a gas turbine power plant. And then depending on the area where it's mounted, the emissions standards for that plant might be really strict, so they have to run within a real tight air fuel mixture to keep their emissions level at a certain standard so that they don't exceed that and get in trouble from the EPA. So depending on the OEM and I guess the end user plant, they might monitor the combustion dynamics all the time, and it might just be an information screen, which would be like a passive screen, so that if an operator or a tuner sees something not running right, they're able to adjust that on the fly manually at the plant. And then there's an active system, so that's actually tied into the control system that can actually sometimes provide shutdown if necessary, if certain extreme limits are reached, or kind of a newer product that's been out for probably 7 or 8 years, maybe even 10 now, is there's an auto tune system. So it's tied up to the combustion dynamic system all the time, and it can automatically tune the gas turbine while it's running. So it's always going to meet the emissions and fuel air mix ratios that's set up in it all the time. So that's a real neat system. It's really expensive, but there's some statistics out there that show that it pays for itself in a very short time. So, the benefits of measuring combustion dynamics, it keeps your unit safer. So, if you don't have that information and there's a problem, it could cause an event that's dangerous to plant and plant personnel. You can run your turbine longer, make it more available if it's a peaker type of plant, so it can run when necessary if you're monitoring combustion dynamics properly. Again, lowering emissions. Then you can also get a lot of diagnostic stuff out of a CDMS system if you have it set up that way. So you can look at different spectra on each combustor, different frequencies within the spectra. You can set alarm values on each frequency band, which a lot of plants do nowadays. You can have a peak hold when you get into a transient condition, which is convenient for long-term monitoring and trending. You can see what's been going on. We've got this. Some systems have what's called a patchwork spectrum, where the system will let you know which combustor has the highest amplitude in each band, so you'll know if, there could be a possibility that the fuel nozzle itself is not right in that one combustor. That's a possibility. There's other things as well that could be wrong. And then you can do different trends, multivariable trends, by band, by combustor, and this is a kind of a common monitoring parameter that plants do. Some plants even, you can look at that remotely. I can pick up his phone and some systems and look at the overall trend of the turbine. Like, is it Sunday afternoon and you wonder what's been going on at the plant? The plant manager or the maintenance manager can go look at that to make sure everything was working right over the weekend. And you can see that in a real quick and easy method. Just pop it up and look at that. Typical combustion monitoring hardware is a sensor system, which we supply, and that's going to be a dynamic pressure sensor, extension cable. So the sensor itself is going to have a hard line, high temperature cable on it, and depending on the length, how far you need to get out of the heat zone, you're going to stop there with that cable and then go on to a soft line extension cable. And then that extension cable is going to run into a charge amplifier and signal conditioner. So that's the parts that we can provide to a system. From there, and we don't have these next products, but they're combustion monitoring systems. So there's several companies out there that make this system. So that takes the output of our sensor system and does all the signal processing and gives all the outputs, and also connects to potentially an auto tune system. And if you don't have that, there's no need to have a sensor system. So, we provide the sensors to most companies that provide the combustion monitoring system, the data collection system, if you want to call it, or DAC. So there's also sometimes in a plant, most plants will have a control system screen in their operator control room where they can look at data in real time. And it's typically recording, so they can look at trends later on. But the operators will have 14 or 16 squares on a screen, which is each combustor looking at the oscillations in the combustion chamber on each one of those screens. And then again, auto tuning system could be part of a CDMS system. So why do we need high temperature dynamic pressure sensors? So we talked about the other style, the remote and the close coupled sensors. So why do we need a high temperature sensor? It's going to give you the best signal accuracy and clarity. So if you were to compare the signals from each, this is going to be the absolute best. It's not going to be any noise in it or anything but the actual signal coming from that sensor when it's mounted properly. It's a non-turbine sensor. It can handle combustor temperatures around 1200 degrees, sometimes a little more. There's no purging necessary. Those other systems, specifically the remote, those systems need to be purged with nitrogen on a regular basis, and that's not real convenient. I've seen a lot of plants out there over my time where they run out of nitrogen and nobody knows, and the tanks are empty. Nobody's watched it. So what happens in those tubes, if they aren't purged with nitrogen on a regular basis, they start to get moisture inside and can give them some really, really ugly looking readings coming out of that. So again, and part of that is maintenance. So if those tubes get plugged, it requires a lot of maintenance to keep those clean. Sometimes they got to replace a tube, especially an infinite tube system, if it gets too plugged up, and it's really expensive to replace those. Nowadays, I think all OEMs are using high temperature dynamic pressure sensors on the turbine. I don't think anybody's going the other routes anymore that I can think of. So on installation of the sensors, you know, depending on the OEM, there might be 10, 14, 16, 18, 20 combustors, but each combustor is going to have a dynamic pressure sensor, or on some newer systems made by one OEM, they're putting two combustion high temperature dynamic pressure sensors on the combustors. So they're putting two on each. And what they're doing with that, with the two, is they're looking at different things with each sensor. One's looking at the normal stuff we're looking at, and then the second sensor is looking at some other information that they can't get from the other sensor. And it's also used, besides that, for redundancy. If one fails, they can still keep their combustion dynamics in line. Kind of, you can see in the picture there where the sensor's mounted, that square on the top is kind of showing a combustor. The lower picture on the right is kind of where the sensor is mounted, where you see the red circle. It's a little hard to see these, I understand that. Apologies, but that's kind of the best we got. So yeah, the sensor's mounted so that the tip is just inside the liner. So where all the combustion is going on is where the tip of the sensor is mounted, just outside of that, as you can see in that picture. They're usually mounted either a casing surface. So early on, when there weren't quite as hot as pressure sensors as there are today, they would mount on a casing because it's not quite as hot there. So they're mounted more on the casing there, and then as temperatures were able to go up in the sensors, they went more for a flush mount within the liner there, as you can see in that picture. This is four different methods that they use for mounting. We have sensors that mount in all these different parameters. You know, the clamp nut, which is probably my favorite mounting method, where it's just a nut that moves back over the top of the sensor and screws into the casing of the combustor. There's mounting screws. It's the sensor that would mount up on top of the casing, and there's some screws that hold it on. There's a swage lock style sensor, and that's typically used on retrofits. It's not used by OEMs on new builds. And there's also a threads integral to sensor, which is my least favorite way to mount these sensors, because if you got a big hardline cable attached to the sensor and you're trying to screw it into the combustor, it's kind of painstaking. Another example of an installation this is a drawing actually from an OEM, is kind of showing where a vibration sensor is mounted, and then the pressure sensor is mounted usually right by a fuel nozzle in that area on the combustion basket. It's kind of an overview of the installation methods I just talked about. The clamp nut with a flush mount or recessed mount. Mounting screws, you don't use that for a recessed mount where it goes inside. So you're only able to use, a flush mount, you're only able to use it on a recessed mount, like that drawing. And then the swage lock, we don't supply swage locks, if anybody was wondering. We just supply the sensor. The swage locks are pretty available from, swage lock authorized distributors. And then the threads integral to the sensor, that mounting method you can see there. Like I said, that's really kind of a pain to mount sensors that way, especially if the hardline cable is really long. This is the system, what products that we provide for it. You can see all the different styles and types of sensors we have there. And then there's extension cables, and depending on the temperature, where the cable is going to be. There might be a hard line cable like that one in the top that's mounted till it gets out to a cooler area. And then it would go to a soft line cable like that extension cable, or if the integral cable on the sensor is long enough, you just go right to an extension cable, which is typically the way it's done today. Most OEMs right now will have a hardline cable on the sensor that's integral, and it might be 12 to 18 inches. That's pretty typical, and that gets them out of the hot zone where they're able to go to a regular soft line cable. And from the cable, again, we go right to different charge amplifiers, depending on customer, depending on the OEM, might have a millivolt output or it might have a microamp output, depending on who it is. Again, recap, why are high temperature pressure sensors installed in gas turbines? They can handle the temperature of most combustors, and depending on the mount, I've seen, I don't think there's any combustor today that we can't mount one of our sensors on. I've never seen any go really above 12 or 1300 degrees. So, we have ICP style of pressure sensors, but they can only handle 250 degrees. So that limits the installation of where it can be. The signals, most accuracy of the signal is with a high temperature sensor mounted directly onto the gas turbine. And the maintenance is a lot less than the other style of sensors that we talked about, the remote and the close coupled sensors. So why are differential charge pressure sensors used? Again, and we use a differential charge amplifier, and the main reason that's used is it provides noise rejection. Charge mode sensors are very, very susceptible to noise, and a differential charge amplifier actually cancels out the noise by design. It takes and switches the positive and negative leads as necessary. It's kind of a technical, complicated type of device, but it's able to cancel out the noise so that you're just getting the actual signal from the sensor, and then it's able to take that sensor and provide an output, typically a voltage output. So, a lot of times when I've talked about pressure sensors, people have asked about, well, what is the sensitivity coming out of the sensor system? Is it voltage, or what is it if you're having a charge signal come out of the sensor? What is it going to be coming out of the charge amplifier? So, and what is a sensitivity? I went through this recently with a customer that bought a system that they wanted to configure their CDMS system side. So, I went through them, and they had a 176 style probe, which are high temperature probes, are 176X something, depending on the probe. And that probe is, the one they had was the style here, 176A03. Then in its sensitivity is 16 picocoulombs per PSI. So from the sensor, we went to an extension cable. Their length that the customer had was actually 30 feet. So, and the length of that doesn't really matter for the signal. Charge systems can go pretty long. I've never really seen them over about 30 meters though, which is around 90 feet. So from there, it goes into a charge amplifier, and our standard EX682A40 charge amplifier has a conversion factor of 10 millivolts per picocoulomb. So you take that 16 picocoulombs per PSI sensitivity of the sensor, multiply it by the 10 millivolts per picocoulomb of the charge amplifier. When you do the math there at the bottom, the picocoulombs cancel out, and you get 160 millivolts per PSI. So that's the number that they would put into their sensitivity section of their CDMS setup would be 160, or, you know, depending on the cal sheet of the sensor, it might be 15.4 or whatever. So if they would put 15.4 times 10, they'd get 154 millivolts per PSI. So that's what they would put in their sensitivity section. A couple slides about testing the CDMS sensor system. This Endebco sensor simulator, it's a 4830B, is a really nice unit for testing not only charge systems, but also ICP sensors. It can simulate an ICP sensor or a charge output sensor. You can choose a frequency, you can choose a sensitivity, you can choose an amplitude, all within this unit to simulate the sensor that you're testing. So system testing, you don't really need to test the sensor, and this is my opinion. I mean, you can remove the sensor from the equation to see if it's working or not. So you remove the sensor from the extension cable, and you use a adapter cable from that extension cable, such as our 045 M51 adapter, which would go right onto the extension cable. And then there's a BNC connector on the end of the sensor simulator, and you plug it into that, and you set up your parameters within the simulator, your sensitivity and your frequency, amplitudes, and you just turn it on, and you can see right away in the customer's system if it's working. You can check each frequency band if they're using frequency bands, which usually they're looking at 3 different frequency bands in the CDMS system. So you can verify the integrity of that whole system without the sensor. So if that's good, then you know the sensor's not working. So if the customer doesn't have a spare sensor, they would probably, the best thing they could do would be to send it to PCB or the mobile shop to get it tested, calibrated. There are some sensor testing devices for field, but they're really inconvenient. They're not easy to use. They don't provide a great test. So, you know, I think this is a real, I'm going to say, cheap and easy way to test the system and find out if the sensor's good or not. But, you know, our sensors don't typically fail. You can see that sensor now. It was damaged because it got hit by something within. It was installed inside the combustor too far, so it got hit by something within the combustor. Like I said, the sensors don't fail unless they're abused, mishandled, you know, installed improperly. They don't just fail when they're in normal use. You know, problems with the measuring chain without the sensors usually related to grounding. The wiring is wrong on the charge amplifier. Sometimes people tend to mix up the ground on there. And then another big problem I've run into is the scaling within the data acquisition or CDMS system. The scaling's set too high, so they don't see anything in the bottom of the display. There's no data. So you fix the scaling, make it where it actually should be, you're going to see data. So that Endebco 4830B is a really wise investment for troubleshooting a system, and it's not very expensive either. It's a great tool. I use one when I go on the field sometimes to test the system for a customer. So, you know, why would anybody want to switch, or if they run into somebody else's high temperature pressure sensor out in the field, or, you know, any of you guys on the phone have somebody else's sensor, you know, and you're interested in talking to us, you know, we have a drop-in replacement for most major OEMs. You know, I'm going to go on the limb and say pretty much all of them will have a replacement sensor. of many models. The most common ones are in stock and ready to ship. You know, we can ship them right away. You're not going to have any long lead times like some other companies have. The high temperature sensors are all made with our UHT12 crystal technology, which is a really good type of crystal to eliminate spiking during temperature transients, which a lot of others, high temperature sensors have this. When the temperature is changing, they might have some transient spikes. Our sensors are all intrinsically safe, and most of the time they're less expensive than to buy from the OEM directly. And you know, some of our OEM sensors you can't buy that same sensor from us, but you can buy a replacement. If it's our OEM, you can buy a replacement sensor from us. It's going to be less expensive than the OEM, and we can work out the system so that you can use a regular PCB sensor instead of the OEM sensor. Don't forget, that was it for this presentation. Talking about next week is wireless. I think from our group with PCB, Vic Viola will be talking about the wireless system next week. And visit the Mobile Shop on YouTube. So all of our series presentations are on the Mobile Shop's YouTube channel. This presentation will be posted there shortly as well. And with my wonderful voice, it'll be fun. Thank you, everybody, for joining. We really appreciate your time.